Hello, I am Dr. Shrutishrabha Bharali and I welcome you to this lecture video on loop control statements, which is a part of the online course on open source software for academia. In this video lecture, we will thoroughly explore the fundamental concepts of loop control statements in Python programming. Loops are essential for automating repetitive tasks, and this session will introduce you to the two primary looping constructs available in Python: for loops and while loops. Through a wide range of practical real-life examples, in this video lecture, you will learn how each loop works, when to use them, and how they can help you simplify and streamline your code. You will also see how loops can be paired with else clauses, which execute a block of code once the loop concludes normally, adding flexibility and control to your program. Moving beyond the basic loop structures, the lecture will delve into key loop control statements that help modify the normal flow of loops, that is break, continue, and pass. In this lecture video, you will discover how the break statement allows you to exit a loop immediately when a specific condition is met, making it useful for stopping early once the objective is achieved. The continue statement presents a way to skip the current iteration and move directly to the next one, which is especially helpful when certain conditions need to be bypassed. Additionally, you will understand the role of the pass statement, which acts as a synthetic placeholder when no action is required, but the structure of the code still needs to be maintained. All these concepts will be demonstrated through clear, beginner-friendly examples to help reinforce your understanding and build your confidence in applying loops and control statements effectively. By the end of this lecture video, you will have a solid foundation in using loops and loop control statements in Python, enabling you to write more efficient and logically structured programs. Let us begin with loop control statements. In a program, each statement is typically executed only once during the normal sequence of execution, following a top-to-bottom flow. For instance, a conditional statement such as if statement is evaluated and executed by Python only one time when the program encounters it. However, there are many situations in programming where we may need to perform a specific task multiple times instead of just once. In such scenarios, it becomes necessary to repeat a particular block of code several times, depending on a certain condition or until a task is complete. To achieve this repeated execution, Python provides loop control statements. These statements allow a program to execute a set of instructions repeatedly, either for a fixed number of times or until a particular condition is met. By using loop control structures, programmers can automate repetitive tasks efficiently and avoid writing the same code multiple times. Loop control statements are essential tools in programming that help manage repeated execution and improve the efficiency and readability of the code. Some of the common loop control structures are while loop and for loop. Let's begin by understanding how the while loop functions. The while loop in Python is a control structure that allows a set of statements to be executed repeatedly based on a given condition. It is particularly useful when we want to perform a task multiple times, but we do not know in advance how many times the repetition should occur. The loop continues to execute the group of statements as long as the specified condition remains true. Once the condition becomes false, the loop stops and the program control moves to the next statement after the loop. The syntax of the while loop is displayed on the slide. Here, statements represent one or more statements. The Python interpreter first checks the condition. If the condition is true, then it will execute the statements written after the colon. After executing the statements, it will go back and check the condition again. If the condition is again found to be true, then it will again execute the statements. Then it will go back and check if the condition is true. This cycle continues until the condition evaluates to false. Once the condition becomes false, the interpreter exits the while loop and continues with the rest of the program. This type of loop is often used when the number of repetitions is not known in advance and the repetition depends on a dynamic condition such as user input, counter variable, or a status flag. Let us look at an example to understand the working of while loop. The first line in this program is a comment and the second line initializes a variable x with the value 1. This variable will act as a counter to control the number of times the loop runs. The third line, while x is less than equal to 5, is the condition of the while loop. The loop will keep executing as long as the value of x is less than or equal to 5. If the condition is true, the body of the loop will be executed. If the condition becomes false, the loop will terminate and control will move to the statement after the loop. The fourth and fifth line have the same indentation. Hence, both these statements constitute the body of the loop. In fourth line, it prints the message inside while loop, followed by the current value of x. The fifth line increases the value of x by 1 after each iteration. This update is necessary, otherwise the loop would run forever. It will become an infinite loop since x would always remain 1. After the loop condition becomes false, that is when x becomes 6, the program exits the loop and executes the next statement, which is the sixth line of the program. This line is printed only once after the loop finishes. The output of the program shows that the loop runs for 5 times, printing the value of x from 1 to 5. Once x becomes greater than 5, the loop stops and the final message is printed outside the loop. Let us look at another example. The program here uses a while loop to print numbers from 100 to 1000 in steps of 100. It starts with x equal to 100 and checks if x is less than or equal to 1000. If the condition is true, it prints the current value of x and then increases x by 100 using the line x plus equal to 100. The loop continues until x becomes greater than 1000. As a result, it prints 100, 200, 300 and so on up to 1000 as is clearly shown in the output. Let us look at another example. The first line of the program here is a comment that the program will calculate the sum of n natural numbers. In the second line, the variable sum, which will store the final sum value, is initialized to 0. In the third line, x is initialized to 1 because we are summing natural numbers starting from 1. In the fourth line, the program asks the user to enter a natural number n. This number defines how many natural numbers will be added, that is from 1 to n. The while loop runs as long as x is less than or equal to n. In each iteration, the current value of x is added to sum. Then x is incremented by 1 to move to the next natural number. After the loop finishes, that is when x becomes n plus 1, the program prints the final sum value. It can be seen in the output. The user enters 5, so the program calculates 1 plus 2 plus 3 plus 4 plus 5, which is 15, and the program prints out the value 15. Next, let us move on to the important concept of infinite loops. An infinite loop is a loop that continues to run endlessly and never stops on its own. This happens when the loop's terminating condition is either never met or is missing entirely. As a result, the loop keeps executing repeatedly, which can lead to the program becoming unresponsive or consuming unnecessary system resources. Infinite loops are generally undesirable and should be avoided, especially in situations where the program needs to complete tasks and exit properly. Both while loops and for loops can result in infinite loops if the loop conditions are not correctly defined or updated. It is very important for programmers to understand how and why infinite loops occur so that they can write safer and more efficient code. Let us look into this example for infinite loop. This program uses a while loop that checks if I is less than 5. Initially, I is set to 1 and the condition I less than 5 is true. The loop prints the value of I, which is 1. However, there is no statement inside the loop to change the value of I, like there was in the previous examples. Since I here remains 1 forever, the condition I less than 5 is always true. Hence, the program enters an infinite loop, continuously printing 1 over and over without stopping, as can be seen in the output. We have to press Ctrl C here to stop the execution of the program. Next, let us move on to the concept of for loop. The for loop in Python is a powerful control structure that is particularly useful when we need to iterate over the elements of a sequence, such as list, tuple, string, or a range of numbers. The for loop allows us to process each item in a sequence one by one, executing a specific block of code for each element. This means that if a sequence contains multiple elements, the for loop will automatically repeat the given group of statements for each element in the sequence. The number of iterations performed by the for loop depends entirely on the number of elements present in the sequence. Once all elements have been processed, the loop ends and the program continues with the next statement following the loop. The for loop simplifies repetitive tasks, especially when dealing with collections of data, and makes the code more readable and efficient. The syntax for loop is displayed in this slide. Let us break down the syntax. The for keyword starts the loop. The var is the loop variable that takes the value of each element in the sequence, one at a time during each iteration of the loop. The in keyword is used to specify that the loop will iterate over the items in the given sequence. The sequence can be any object which can be iterated over like a list, tuple, string, or range function. It contains the values that will be assigned to var in each loop cycle. The statement block of code are indented and will be executed once for each element in the sequence. Let us look at an example for loop. The first line here is a comment that the program is used to display each character in a string using for loop. The second line creates a string variable named sent, which is for sentence, which is used to store the text MOOC on OSSA. The third line is the for loop that will iterate through each character in the string variable sent. In each iteration, the variable ch will hold one character from the string starting from the first character to the last character. The fourth line is indented, which means that this statement is part of the for loop. This line will print the current character on the screen. It will print each character on a new line. We can see in the output that the program goes through the string MOOC on OSSA one character at a time and prints each character on a separate line. First, the first character of the string M is stored into CH and the print statement is executed to display M. Next, the second letter of the string O is stored in CH. The print statement is then executed to display O. In this way, the for loop is executed till all the characters are displayed on the screen. This includes spaces too. Let us now look at the range function, which we will use with the for loop. The range function is used to provide a sequence of numbers. The range n will give numbers from 0 to n minus 1. For example, range 15 will return values from 0 to 14. We can also mention the starting and ending index in the range function. For example, range 4, 8 will return values starting from 4 to 7. Let us look at an example that demonstrates the use of for loop along with the range function to access each character in a string by its index. In the program, the string MOOC on OSSA is stored in the variable sent. The len sent function calculates the total number of characters in the string, including spaces, and stores it in the variable n. The for loop uses range n to generate a sequence of numbers from 0 to n minus 1, which represent valid index positions in the string. In each iteration of the for loop, sent I accesses the character at the current index I and print sent I prints it. As a result, each character in the string is printed on a separate line. The output of the program prints each character of the string MOOC on OSSA on a separate line, including the spaces. The step size can also be specified in the range function. The step size represents the increment in the value of the variable at each step. For example, range 0, 15, 3 will give numbers from 0 to 14 in steps of 3. This means that we need to add 3 to each number to get the next number. So, we will get the numbers 0, 3, 6, 9 and 12. Let us look at a program to check this. This program uses the range function with a step size to generate numbers from 0 to 14 in steps of 3. As already explained, range 0, 15, 3 means start from 0, go up to but not including 15 and increment by 3 each time. So the values generated are 0, 3, 6, 9 and 12 as can be seen in the output. Let us see another example. The program here demonstrates how to use a for loop with the range function to display numbers but in descending order. The code range 15, 0, -3 means the value of I will start from 15 and it will stop before reaching 0 and decrease the value of I by 3 in each iteration. So, the loop generates the values 15, 12, 9, 6 and 3. Each of these values is printed on a separate line using print function. This for loop is useful when we want to count backward with a fixed step size. We can also use the for loop in Python to access and process the individual elements of a list. A list is a built-in data structure in Python that allows us to store a collection of values or items which can be of the same or different data types. Since a list is a type of sequence, the for loop is particularly well suited for working with it. By using a for loop, we can automatically go through each element in the list one by one without needing to manually manage index positions. Let us now look at a simple program that demonstrates how to access and display the elements of a list using for loop. This program defines a list named mylist containing four elements: an integer 2, another integer 4, a floating point number 8.5, and a string mook. The for loop is used to iterate through each item in the list. In each iteration, the variable ele, which is for element, takes the value of one element from the list. The print ele statement prints that element on the screen. We can see in the output here that each statement of the list is printed on a separate line in the same order in which they appear in the list. In Python, it is also possible to use an else clause in combination with both for loop and while loop. This feature is unique to Python and may not be available in many other programming languages. The else block attached to a loop is executed only when the loop finishes normally, meaning it completes all iterations without being interrupted by a break statement. If the loop is exited prematurely due to a break, the else block is then skipped. This allows developers to write additional logic that should run after the loop has completed its task entirely. It is especially useful in search operations where the else part can indicate that an item was not found. Let us look at an example to understand this. In this program, a list named mylist is created containing the elements 2, 4, 6, 8 and 10. The user is then prompted to enter a number which will be searched within the list. The for loop goes through each element in the list. Inside the loop, it checks the condition if val is equal to le. If the user's input matches an element in the list, it prints element found in list and uses the break to stop the loop immediately. The else block is associated with the for loop, not the if statement. It runs only if the loop completes without executing the break statement. In other words, it will print element not found in list only when the value is not present in the list. This can be seen in the output for two different cases. For the first case, when the search value is 6, the match is found in 3 iterations of the loop. So the program prints element found in list and the loop then breaks immediately, so the else block is skipped in this case. But for the second case, when the search value is 20, the element is not found in the list. Since the loop finishes without finding the value and no break occurred, the else block executes here to print element not found in list. In Python programming, it is possible to place one loop inside another. This means that we can have a for loop inside another for loop, or even a for loop inside a while loop, and vice versa. When one loop is written within the body of another loop, this is called nested loops. Nested loops are useful when we need to perform repeated actions within another set of repeated actions. Each time the outer loop runs once, the inner loop runs completely from start to end. This allows us to perform more complex iterations and control the flow of execution in a structured way. The program here uses a nested for loop to access and print elements from a two-dimensional list. The outer loop handles rows while the inner loop processes each element within those rows, effectively displaying the data in a matrix format. In the program, the variable data is a list of lists. It contains three inner lists: 1, 2, 3, 4, 5, 6, and 7, 8, 9. The loop goes through each row, that is each inner list, one by one. First row, that is 1, 2, 3, then the second row 4, 5, 6, and finally 7, 8, 9. For each row, the inner loop goes through each element in the row. It accesses the numbers inside each list and prints them. This prints each element in the row on the same line, separated by a space. The end space argument prevents the default new line after each print. After printing all elements of a row, the statement moves the cursor to the next line. It ensures that each row of numbers appear on a separate line in the output. Next, let us look at the break statement. The break statement is used to interrupt the normal flow of a loop and exit from the loop immediately, whether it is a for loop or a while loop. When the break statement is encountered inside the body of a loop, the Python interpreter stops executing the loop, even if the loop condition is still true or the sequence is not fully traversed. As soon as the break statement is executed, the control of the program jumps out of the loop and continues with the first statement that comes after the loop block. This makes break a very useful tool when we want to terminate a loop early based on a specific condition. Let us see how the break statement works using an example. This program demonstrates the use of break statement to exit a while loop prematurely. In the program, the variable x is initialized with the value 15. According to the while loop condition, the loop runs as long as x is greater than 1. So the loop will keep executing until the value of x becomes less than or equal to 1, or unless a break is encountered. Now, in each iteration, it prints the current value of x and the value of x is decremented by 1. After decrementing, it checks if x is equal to 10. The break statement is triggered when x becomes 10 after decrementing. This causes the loop to stop even though the while condition, which is x greater than 1, is still true. After the loop exits due to break, the program prints the last statement in the program outside loop. In Python programming, the continue statement is used within a loop to skip the remaining code in the current iteration and jump directly to the next repetition of the loop. When the Python interpreter encounters a continue statement inside a loop, it immediately stops executing any of the statements that follow it within the loop body for that particular cycle. Instead of exiting the loop like in the case of break statements, here it simply moves control back to the beginning of the loop and checks whether the next iteration should run based on the loop's condition. This is useful when we want to skip certain values or steps under specific conditions but still want the loop to continue running. Let us look at an example to understand how the continue statement works. In this program, the variable x starts at 15 and is decremented by 1 in each iteration of the loop. The loop runs as long as x is greater than 10. When x becomes 12, the continue statement is executed, which skips the print statement and immediately moves to the next iteration of the loop. As a result, the number 12 is not printed. Once x becomes 10, the loop ends and the message outside loop is displayed. Now, let us look at the pass statement. The pass statement in Python programming is used as a placeholder to indicate no operation or do nothing. It is often used in situations where a statement is syntactically required by the language but where the programmer does not want any code to execute at that point. The pass statement does not affect the flow of the program. It is simply ignored by the interpreter. Essentially, the pass statement allows us to write code that is syntactically correct while postponing the actual logic to be added for later. This is useful during the early stages of development when we are designing the structure of functions, loops, classes, or conditional blocks but have not yet decided what actions they should perform. For example, if we want to create a function or a loop but are not ready to implement its contents, we can insert a pass statement to avoid errors caused by an empty code block. It ensures that the program runs smoothly without doing anything at that particular spot. Let us look at an example to understand this. This program uses the pass statement to represent a block of code that does nothing. The variable x is assigned the value 10 and the program checks if x is greater than 0. Since the condition is true, the if block is executed, but instead of performing any operation, it simply contains the pass statement as a placeholder. This helps keep the syntax valid while leaving room for future code to be added. The else block is ignored in this case because the condition is not false. After the conditional check, the program prints program ends, showing that the program continues normally even when pass is used. Let's take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. Which of the following is a loop control statement in Python? Take a moment to think about your answer. The correct answer is option D. Now here is the second question. How many times is a statement normally executed in a program's top to bottom flow? Take a moment to think about your answer. The correct answer is option C, only once. Here is the next question. What happens when the condition in a while loop becomes false? Take a moment to think about your answer. The correct answer is option C. Control moves to the next statement after the loop. Here is the next question. What is the output of the code that is given on the screen? Take a moment to think about your answer. The correct answer is option A. Now here is the next question. What is an infinite loop? Take a moment to think about your answer. The correct answer is option C, a loop that never ends. Now here is the next question. When does the continue statement affect loop behavior? Take a moment to think about your answer. The correct answer is option C, when we want to skip current iteration. Now here is the next question. What is the function of the past statement in a loop? Take a moment to think about your answer. The correct answer is option D. It performs as a dummy operation. Now here is the next question. What is the output of the following code? Take a moment to think about your answer. The correct answer is option B. This lecture video offered a comprehensive introduction to loop control statements in Python. It covered the use of for and while loops in detail, illustrating their functionality through a variety of practical examples. The video also demonstrated how these loops can be effectively combined with else statements to perform additional actions after the loop execution. Furthermore, key loop control statements such as break, continue, and pass were introduced, with clear explanations and examples showing how they influence the flow of loops in different scenarios. Thank you for watching this video.